All right, well, welcome back. My school season is over, so I ended up passing all my classes, which is crazy business. And so we're just gonna practice more. We're gonna do more questions. I'm gonna redo some of the questions that have already been posted on the channel, just because I need practice, especially with my math. My math isn't great. So, but there will definitely be a repeat of concepts and questions. I don't want to go over something. I don't want to go over something that I'm not certain about. So I don't want to look at a new textbook or look at something I'm not too familiar with. I want to make sure that even if what I'm putting on YouTube isn't great content or isn't very well explained, it's at least correct. There's a man named Bob, and Bob was asked the following question: would you take $1 million or toss a coin for a 50-50 chance to win $10 million? If Bob's answer was, I will toss a coin for a 50-50 chance to win 10 million, does this mean that Bob is risk neutral? Well, this is easy. So when P equals 1, when there's a 1 million gain, okay? I'll write down all the zeros, why not? Okay? So there's a 100% chance of winning 1 million. There's a P equals 0.5% chance of winning 10 million. So you could construct a comprehensive or more you could do this if you wanted to. Expected utility equals 0.5 times 10 million. And this is correct. You're just going to end up with your answer, which is 5 million. But you can already derive that just by looking at this. So there's no real need to list this out, but we can write as our answer, therefore, yes, Bob can be risk neutral or risk loving. Now I'm going to ask a follow-up question. The follow-up question is, if Bob is risk adverse, will he choose the 1 million all the time? Okay, and I'm going to prove that wrong. So, expected utility, let's make Bob's u of x equal x to the power of 1/2. So this means Bob is risk adverse. So our expected utility is equal to 1 million. Excuse me. 1 million 1/2, and our expected utility 0.5, 10 million power 1/2. Okay? So this is for certainty. This is for the certainty chance. I could have made my notation better. Okay, so this is our conclusion. A person who is risk adverse might not choose the certain amount, right? The 100% guaranteed amount might still be the lower expected utility, right? So it depends on two things. It depends on the difference of utility. So 1 million compared to 10 million, that's a huge difference. It has to do with the probability, and it obviously has to do with the level of risk aversion. Because you can have someone who is risk adverse like this, like the power of 1/2. Well, that's way different than someone who's like super risk adverse, like 1/4, right? So that'd be 0.25. That's super risk adverse. And so maybe that person would be more likely to choose the guaranteed 1 million. Me personally, I would choose the guaranteed 1 million because I'm $1 million richer, right? So maybe I am more risk adverse than the average person. I don't know. But it's definitely an interesting look at risk aversion, because it's not always the case. It is not always the case that the person who is risk adverse is going to take the risk adverse option. Okay? This is what it's trying to prove. Because technically this is the more risky option, and the person with the risk adverse utility is still choosing it because it is higher. Thank you for watching.